So we're going to be talking about motion graphs. For this first motion graph, we have a position time graph. So, and our example is that, let's say this was a hiker. The hiker starts at a position further up. Let's say, this is where you are. The hiker is this far in front of you. Then the hiker walks down this way until they're behind you. And the hiker has a little bit of acceleration right here where they see that curve. That curve is acceleration. And then the hiker starts moving back up in a positive direction. And then the hiker stays still here. And then this hiker walks all the way up here. And then we have some more acceleration. We have a couple bumps here where the hiker accelerates or deaccelerates. And then again, the hiker stops with this flat line and then continues down and then stops right about there. So that's our first position time graph. We'll look at another one after we look at the velocity time graph. So this one is a helicopter. This velocity time graph, I'm not sure how well you can see it, but there you go. And then the helicopter starts here, increases in velocity, speeds up. So this is an example of acceleration, then this is constant, then this is an example of slowing down. It's also acceleration, you might call it acceleration, deacceleration. And then the helicopter, so the helicopter speeds up, stays constant, slows down, speeds up, stays constant. So in that case, we don't know what the distance for this necessarily is, but we are able to gauge the speed. That's what the velocity time graph is for. We don't have the position of the hiker. If we had numbers written down here, we could tell, okay, so the hiker started at this position, they ended at this position, then we would know their displacement based on that. But the velocity graph gives us different information. So one moment as I find the last one. All right, speedboat. Okay, so this is another position time graph. So in this case, the speedboat actually starts behind the line at a lower position. So let's say we have a lake here. And let's say this line here is about the midway point across the lake, trying to get over here. So this is positive, this is negative. The speedboat starts at the shore here, then it goes up, down, up again, and then it doesn't move for a little while here. That would be like turning off the motor or slowing it down enough that it's not really moving. You're sort of just treading water. And then it moves down and then it jerks up, and then we have another example of acceleration with this bump around up and then down, and that's sort of bent. So that's sort of downwards acceleration, and then it goes out and then inwards. So the speedboat starts down here, it ends up here. So it ends up at a further position than where it started, but it doesn't end up above the time line, the x-axis. So those are three graphs, and that's how you would graph the movement of objects. Yeah.